Under API 682 and ISO 21049, the premier standard for mechanical sealing systems, applicable for hazardous, flammable, and/or toxic applications, a seal is confirmed fit for purpose by measuring the pressure drop on 28 liters, 1 cubic foot of sealed air over 5 minutes. This video shows a seal which was able to leak 270 to 1,300 times the 5.6 grams, 0.2 U.S. fluid ounces per hour maximum, which the standard specifies, yet still passed the air test. A control test confirmed this test rig was leak-free with zero pressure drop from 25 psi 1.7 bar over the test period. Based upon engineering calculations, a plug with a 0.2 mm 8/1000ths of an inch hole was manufactured and added to the rig. As predicted, this assembly narrowly passed with a maximum allowable 2 psi or 0.14 bar pressure drop over 5 minutes. A third test added a well-manufactured, fit-for-purpose mechanical seal fitted with the same plug and hole. The result was the same, confirming that a seal assembly with a 0.2 mm 8/1000ths of an inch hole can pass the current air test. When this test was repeated with an air volume of only 1.5 liter or 0.053 cubic feet, the seal assembly with the hole dramatically failed with a 22 psi or 1.5 bar pressure drop, demonstrating that a lower air volume test is far more sensitive to leakage. Without the hole, the seal allowed zero pressure drop even with this reduced air volume, showing that a well-designed and manufactured mechanical seal can still pass the strict test. To predict real-world leakage, the orifice from the previous test was installed into a nitrogen pressurized water vessel. Even at a low pressure of 2 bar or 29 psi, the liquid leakage rate was 1,500 grams per hour or over 50 U.S. fluid ounces per hour. This is 270 times the stated maximum for an API 682 and ISO 21049 seal qualification test. When the test was repeated at a typical pressure of 7 bar or 102 psi, the liquid leakage rate was 3,000 grams per hour or over 100 U.S. fluid ounces per hour. This is about 540 times the stated maximum. Finally, the test was repeated at a high pressure of 40 bar or 580 psi, which is close to the maximum pressure limit for a Type A seal under the standard. The liquid leakage rate at this pressure was 7,500 grams per hour, or over 250 U.S. fluid ounces per hour, 1,300 times the stated maximum allowable leakage rate. These tests were performed with water. Imagine the real-world risks if the sealed liquid was a flammable fluid such as gasoline. Given that API 682 and ISO 21049 is used for hazardous, flammable, and/or toxic process containment, AESSEAL now voluntarily submit all of their API 682 qualified seals to the stricter 1.5 liter or 0.053 cubic feet air test, and end users are encouraged to request the same from their supplier. Note: all pressure indications are in gauge pressure.